All right, so do you have that little activity, hopefully, that you worked on yesterday at the end of the period? We're going to go through the answers to that first. Okay, so this little applet website that you were working on, they're giving us a couple things in this picture. So the black curve is the original distribution. The red one is the distribution of the sample mean. Remember, it's got a smaller standard deviation, it's a little bit taller. And what you see in green is the population mean. So the whole point in creating these intervals is we are trying to estimate the population mean. So what you're seeing when these little samples are taken, they're taking like, I don't know what the sample size was, let's say like 5 or 10 at a time. And then this is the interval that's created from those 10 samples. And we're looking to see if that interval hits our sample mean. So all of them showed up in black when you were doing it, except for there might have been an occasional one in red. And you'll notice that that one was either to the left or to the right of your population mean. So that interval does not contain that value. So these are my answers when I did it. Yours might not be exactly like this. You should have a yes here for sure. Part B. It might be a 9, it might be a 10, it might be an 8, but it's going to be somewhere around there based on the number of hits that you had. Okay, again, these are the numbers that I had when I did it. When I hit reset and did it 100 times, I had 97 hits, which was 97%, but yours, again, might not be that exact number. That's okay. What you should have noticed for number 4 then is if we change the level of confidence, so take it from a 95 to a 99, those intervals, those little lines become wider, they become longer. That's because we are more confident, or there's a higher probability that we will contain the population mean. If we had smaller intervals, there would be a smaller probability that we would hit that population mean. So as the confidence level gets bigger, you should see more hits, more percent containing that population mean as you go, and the intervals are getting wider. Okay, on the back, again, those are my numbers. I got about 84 for that one. Number 6, you can interpret this how you want. This is how I kind of chose to interpret it. I said out of 100 samples, the approximate number of intervals, or the probability that we will contain the population mean, is that confidence interval. And remember, it's all about the population mean. What we are doing is trying to estimate that. It's unlikely that we will have a population mean in most cases because we can't survey everybody in the population. So we use sample information to try to find that. Okay, so that's approximate, might be another word under there, percent or number, whatever. Okay, so if I say I'm 80% confident, I should expect that about 80% of the time I contain the population mean. Or if I'm 95% confident, I can say 95 out of 100 times, or 95% probability that I'm going to contain the population mean. But it all falls back to, will I contain in that interval the population mean? Okay. And then the very last thing at the bottom, we played with sample size a little bit. As the sample size gets bigger, more people are surveyed. So our margin of error, how far off we are, actually gets smaller. So you should have noticed that as the sample size increases, those intervals were getting smaller or narrower, because we can be more confident because we have more data to support that interval we're creating. That margin is getting smaller. All right, so I'll give you a second to write that down. What we're going to do today then on the other handout I just gave you is actually calculate that margin of error and then get those confidence intervals that we kind of are playing with a little bit already. Okay. Any questions on this activity? No. Okay. All right, so on to your other packet now. Okay, so this should be the first slide that you have on there. Actually, do you guys have your purple packet? Maybe. So go to your Z-score chart. You will notice at the bottom of, which side is this? The negative side of your Z-score chart. There are certain critical values listed for you already. So there are common levels of confidence that we have. So this 80%, 90%, 95, 99, those are all there for us, and those are going to be the Z's, the critical values that we're going to use in a formula in a little bit if you have that level of confidence. So sometimes you won't need to calculate this at all, but I'm going to show you where these numbers come from, because you can use this method to get a critical value if it isn't on your chart already, okay? So if I have a confidence level of 90%, that means my C value is 0.9, okay? That means 90% of my data is contained in the middle of my standard normal curve, okay? If I do 1 minus that, I get 10%, or 0.1, and that's the area and the tails. If you guys remember, we did something like this before in the last chapter. Then I can take half of that, 0.05, and that means 5% is in each tail. Okay, again, we did that before, and I can split it in half like that because it's symmetric. And then I can use that 5% to find the critical value of Z. So on our chart, we would just look up 0.05, and that would be in the middle of the chart. We're looking for 0.05 because that's a cumulative area or a probability. And this is one where we were between two values. We're between negative 1.65 and negative 1.64. So the critical value is negative 1.645. On the left, we put a plus or minus in front of that, and that gives us our two critical values of Z. So the negative Z is negative 1.645. The positive Z is positive 1.645. And this is one of the ones that's a common one listed on the bottom for you already. If you look at 90%, you're going to see the 1.645. They always give you the positive value. The plus or minus is going to be in the formula for us. Okay, so you see where that came from? A lot of times you won't have to even like add them up and divide by 2 if it's not between two numbers. We just pick the one that's closest. But this is how you would do it if it isn't a common critical value. It's just you use that as your area in the middle, figure out the area and the tails, and use that to find your Z-score. Okay. All right, formula for margin of error. Margin of error, when we calculate it, will always be a positive number. Okay, and then when we add and subtract it to our confidence, or to our sample mean to create our confidence interval, that's where we're going to see the plus or minus. There's two different ways it's written. This is really the formula that we're using. So in order to calculate the margin of error, you need to know the population standard deviation, which is that guy there. Okay, we've seen that symbol a lot, population standard deviation. If we don't know the population standard deviation, that's going to be a lesson in 6.2, and we're going to calculate it slightly differently. Our formula is going to change just a little bit, but everything in this section, you will know the population standard deviation. N is your sample size, we know that, and then Z is going to be that critical value we just talked about finding. Okay, so we're going to take our critical value, multiply it by our standard deviation divided by square root of N, and then that is going to give us that margin of error that we talked about yesterday. Is going to add or subtract to our sample mean to give us that interval that we're looking for. And then the interval will be wider if we have a bigger confidence level. The interval will be narrow if we have a smaller confidence level. Remember that we want to be normally distributed, or our N needs to be greater than or equal to 30. So that's the same conditions that we saw before in section 5.4, because technically this is still falling under that header of like that central limit theorem. Okay, so as long as one of these conditions is met, we can do this. All right, so in this problem, all we're going to calculate is just the margin of error. So it says, a survey of a random sample of 1,000 smartphone owners found that the mean daily time spent communicating was 131.4 minutes. From previous studies, it is assumed that the population standard deviation is 21.2 minutes. Communicating on a smartphone includes text, email, social media, and phone calls. For a 90% confidence interval, what would be the margin of error for the population mean daily time spent communicating on a smartphone? Okay, so my C is 0.9. As soon as you have a C, you should be able to, from your purple packet somewhere, find a critical value. There we go, Traja, thank you. Of Z. Okay, so a Z sub C. And 90% is the one that we just calculated. It's at the bottom of our little paper here. We can just find the 1.645 is fine. You don't need to worry about the plus or minus right now. We'll get to that when we actually do the full confidence interval. Population standard deviation we need to know. That was given to us. It's 21.2. And then were we given an n on this one at all? Oh yeah, 1,000 is our n value. We were also told, let's see here, random sample size is bigger than 30, so we meet all our conditions. Margin of error, critical value of z times the standard deviation, bless you, divided by the square root of n. So it's 1.645 times 21.2 over the square root of 1,000. 1.645 times 21.2 divided by square root of 1,000 gives me a margin of error of, I'll give it 1 decimal place just because that's how we're rounding in the problem. So it's going to be 1.1 is the margin of error. Okay. And just the positive value is good for that for now. Any questions? Okay. It doesn't ask for it on this problem, but just because we're short on time, let's go ahead and go to the next step. If you want the full confidence interval, you're only one step away. So to get the confidence interval, you're going to take x bar, which is our sample mean, and you are going to add and subtract the margin of error to that. Remember we did that with the number line yesterday, right? The x bar was right in the middle. We just added and subtracted on whatever our error was. So in this one, give myself a little extra room. It told us the sample mean at the top. It was that 131.4. So 131.4 plus or minus my margin of error is going to give me a 90% confidence interval. So 131.4 plus 1.1. If I add it on the high end, it's going to be 132.5. If I subtract it, I'm going to get 130.3. And then a lot of times with these problems, it's going to ask you to interpret your confidence interval. So there's a few different ways you can word this. You would say, let's do the probability one for this one. There is a 90% probability that and this is important, what we're estimating here is the population mean of time spent on smartphones is between, there we go, 130.3 and 132.5. Was it minutes? What did they label that? Yeah, minutes. Okay. The other way you could word it, instead of saying there is a 90% probability, you can say we can be 90% confident that our population mean will be between these. Okay? This is kind of the big idea of this lesson. Do we have questions on that problem or any of the pieces and parts of it? All right, then let's skip over this one because we kind of played with that before. Let's go ahead to this one. All right, it says from a random sample of 36 business days, February 24th, 2016 through 2017, the mean closing price of Apple stock was $116.16. Assuming the population standard deviation was 1027, construct an 85% confidence interval for the population mean closing price and interpret its meaning. Okay, so it's a random sample, check. My n is greater than 30, check, so I can do the problem. Confidence level, my C is 0.85. The next thing I should be able to get from that is a critical value of Z. Okay, and this is an example of one that is not on the chart for us. So here's how we're going to get it. we're going to draw that normal curve. 85% of the data is between two values within a margin of error away from my sample mean. So what percent is going to be in each tail? 5.2. Bigger than that. 7.5. So if I do 100, take away that 85%, I get 15, and then I'm just going to divide it by 2. So you're going to look up an area of 0.075, and we're going to get as close as we can to that. Technically, it could be positive or negative. We're just really looking for the positive one here. Okay, so as close as I can get to 0.075, I can get to 0.0749, which is at a z-score of negative 1.44. Here, for the critical value, you just need the positive one. Positive 1.44 is good. We'll get that plus or minus when we add or subtract it onto our sample mean. Any questions getting that? Okay. All right, other things we know. We know n is 36. We know the sample mean is 116.16. We know the population standard deviation is 1027. In order to get my confidence interval, I need to calculate a margin of error. Margin of error is as follows. My critical value of z, 1.44, times my population standard deviation, 1027, divided by the square root of n, square root of 36. And then everything here is rounded to 2 decimal places, so I'm just kind of following with whatever the problem has in it already as far as rounding. You'll notice, math with Excel will be specific. 1.44 times 1027 divided by 6 gives me 2.46 to 2 decimal places. Okay, so now my interval is x bar plus and minus e. Okay, and my x bar was 116.16. So if I add 246 to that, I get on the high end 118.62. If I subtract, I get 113.7, so I'll say 70. Okay, and then if we're going to interpret that meaning, we'll say we can be 85% confident, or again, you could say there is an 85% probability that, again, the population mean of all Apple stock closing prices is between 113.70 and 118.62 is what that interval tells us. Okay. Questions on that one? All right, we're just going to do one more problem, and then that'll wrap it up for us. Let's do, not that one. This one. Be our last one. Okay. So if we take the formula that we already have for margin of error and we solve for n, the computer's going to be a little angry with me right now. If we solve for n, we end up with this guy. So you could just do a little algebra. You can flip the fraction, square both sides, get rid of the square root, so on and so forth. We end up with this. Okay, so same formula, just moved around a little bit. This formula can help us figure out if we want a certain margin of error. Like, let's say I only want my margin of error to be a 3% margin of error. I can calculate n. I can figure out what's the minimum number of people I need to survey to be able to have that margin of error. So this is something that you would do before you actually do a survey or a project or research on something. You'd figure out, okay, I need my research to have this kind of results. So to get those results, how many people or how many data samples do I need to look at? Okay, so Problem. Determine the minimum sample size required when you want to be 99% confident that a sample mean is within 2 units of the population mean. If they tell you something like this, within 2 units, that's your E, because that's what we are within, right? We're adding and subtracting that E value to our sample mean to be able to get that interval that we're looking for. So E is 2. And we want, oh, and we're told that our standard deviation is 1.4. Assume we're normally distributed. Okay, so we meet our little check there. All right, so n equals, I'm going to need to figure out my critical value of z. I'll come back to that in a second. Times population standard deviation is 1.4. E is 2, and I need to square it. Critical value of z can be found from your paper. 99%, if you look at the bottom there, is one of our common values that's used. If it wasn't, we would draw the curve and figure out what area is in the tail. It's 2.575 is the number that we're going to use. And then you just type it in your calculator. 2.575 times 1.4 divided by 2 and squared, I get 3.249. Whatever number you get here, n has to be a whole number of data values, so we will always round up. We don't round to the nearest because remember this is a minimum that we need. So if we round down, we don't have enough. So even if it was 3.00001, we would round up just to ensure that we have enough data values. So my answer here would be 4 for n. It actually ends up being a pretty small number. Okay. And that is 6-1. Yes?
How much you get, or where did you get the 2.5?
So on your z-score chart, look on the negative side of your z-score chart. It's at the very bottom where it says critical value, see level of confidence. So the 99% one right next to it is that 2.575. If it wasn't on here, you do what we did in that other problem where you draw the curve and shade what's in the middle.
Why does the notice of 2 units?
The 2 units is the margin of error. They're saying whatever interval we get, we want our sample mean to be within 2 units of the interval. Okay, so it's always, they say within this many units or within this many, whatever the unit is, dollars, people, whatever. That's your margin of error there. Okay. All right. 6-1 Math Excel is due on Tuesday night is your next deadline. Okay? Avocado. 17. All right.
Oh.
I posted a video on YouTube. So watch it. It's actually a video from last year, so try to
What's like the main thing that
yesterday we found intervals. We just didn't call them confidence